Samir Haja, who manages a team of product managers, strategic planners, customer marketing managers, and with Microchip. He's responsible for setting and executing the product strategy to deliver their sustainable growth of their data center solutions business unit. He has a bachelor degree in both aerospace engineering as well as electrical and computer engineering from Texas A&M and University of Colorado, Boulder, respectively. And Samir is passionate about building better solutions, not just to create products, but also to grow organizations, strengthen teams, and achieve improved customer experiences. His topic today is a very interesting one: top 3 challenges and solutions for delivering the full premise of CXL technology. With that, I'll introduce you to Samir Haja.
Thank you. Welcome. It's great to be here. Thank you for the great introduction. Before I talk about CXL, I want to reflect back. And I started showing up at FMS about 15 years ago in 2008. And NVMe was in a similar state. It was early. We didn't know what was ahead of us. A lot of pent-up demand for new technology to scale performance behind flash. And it's come a long way. It's been a great journey. And that journey still continues. We see a lot of innovation top of NVMe. I was showing at our booth today. You can see that. And it's good and fun and exciting to be part of the CXL journey. It's like we're starting something great, and product announcements have been coming out. And one great one happened yesterday here with our partners. And I look forward to embarking on this journey, and we'll see what we'll talk about 15 years from now. But before I get there, I want to introduce the Microchip technology to you a little bit for those who are not familiar with it. Microchip has been around about 35 years, headquartered in Chandler, Arizona. It's a semiconductor company focused on delivering total system solutions around embedded products. We shipped about a little over $4.4 billion of product last year. Our fiscal year ends in March, so that's through March of this year. We address a broad set of markets: industrial, data center computing, automotive, communications, aerospace and defense, and consumer appliances. At the core of our solutions are embedded products, so that comes with firmware, software capabilities, a lot of peripherals around them to enable smart connected devices. And our focus from a strategic perspective are on major trends in the industry or globally that impact our lives day to day. Those are like 5G connectivity, IoT, data centers, e-mobility, ADAS, and autonomous driving, as well as sustainability. I represent the Data Center Solutions business unit at Microchip Technologies, where our vision is to manage, connect, and secure the world's information. And we do that by being partners and enablers, where we strive to enable rapid innovation, collaborating with key customers and industry partners to drive the next evolution of data centers. And that next evolution right now for us is CXL, enabled by CXL. What is CXL? So very simply, it allows expansion of memory and coprocessors across a shared memory space. There's been a lot of inefficiencies by the architectures that we've lived the last 20 plus years. We've done quite a bit on top of them, but that ended up, losing steam, so to speak, by not being able to share the memory space, where a lot of time and resources were spent in stranded memory, which results really for a lot of companies that consume lots of memory. It could be hundreds of millions of dollars spending and ultimately billions of dollars over time. So CXL is here to solve that problem and allow us to break through that memory wall by enabling performance at scale with memory semantics, and make sure memory looks like memory when you scale it behind compute subsystem. One of the key feedbacks from our customers when you ask him, how big a system you're going to build, how you're going to deploy CXL, is really to say it's got to look like memory. At the end of the day, that's what's going to draw the line. And looking like memory means the latency attributes, how it behaves when you get to memory and back, has got to stay within that memory range. Previous attempts to solve this problem has hit some other walls, and we learned from them. It looks like CXL is here ready to help us break through those barriers. But to talk that a little bit more in detail, I would like to introduce Steve Pawlowski, our partner from Micron. He's corporate VP and runs our advanced memory system. Steve, welcome.
Thank you, Samer.
And
thank you, everybody. And Samer, thank you again. We've had a tremendous partnership with Microchip. The CXL module, Type 3 memory module that we announced yesterday uses a Microchip controller, and it's with close collaboration with them as we've moving forward. And this is the first instantiation where we expect to get a lot of key learnings, how the ecosystem is going to use CXL, and then eventually migrate to more complex systems. So the next slide, please.
yeah, so Steve, could you talk us a bit about the evolution, where we're at today, where we see CXL taking us, why it's important?
Yeah, this is a nice slide that I shamelessly copied from a colleague of mine that shows, when I started in the 1980s, it was still the mainframe mini revolution. All our work was pretty much done on VAX 11780s. PC was coming along, but until the early 90s when we developed our first out-of-order microcoded engine that we called Pentium Pro internally, but outside it was called the P6. Or inside is P6, and then it became what we called Pentium Pro. We came to the conclusion that in order for, we either had to build big, expensive caches to be able to feed this engine and keep it alive, or we had to, in conjunction with those caches, really control the CPU memory subsystem. And so by doing that, it effectively closed off innovation on the memory side, and it did so until there was the availability of CXL. And as we start to see data blocks getting bigger, when I started, they were 8.5-inch floppy drives. That was the new technology. People were looking at very small files. Now we've got petabytes, exabytes, zettabytes of information that we need to have fairly close to the CPU memory complex as quickly as possible in order to be able to get real actionable data, especially as we move all the way out in the 2025 timeframe where the industry has coined memory-centric computing, where we can bring data into the memory subsystem, save moving it back out to disk, save the energy of doing that, save the time it takes to do that, but be able to really get actionable results quickly. And one of the big places that we're focusing on in terms of our workload development here is the large language generative AI models that will be multimodal and will grow in size and complexity. An architecture like this is perfect for that. And CXL, by not only opening up the memory ecosystem and from that perspective, but also allowing us to bring new technologies that aren't as fast as DRAM, but are faster than NAND, have some persistency, things like that. It'll make it a lot easier for us to put in the platform than we've had in the past. So one of the things that we discuss is what we would call a new tiering model. So CXL 2.0 are the platforms that are going to be announced next year, mid to late next year. And that's just a Type 3 direct attached memory module. As I mentioned, we announced our module yesterday, and our other people have announced modules as well. And it's basically for the big use case that we see for that is really memory tiering, where the software is sophisticated enough to be able to bring data into the CXL memory card and then swap that data in and out with DRAM. So DRAM is really kind of the hot tier, and then the cold tier or the warm tier is really the data that's sitting in CXL. So you don't spend a whole lot of time going back and forth to memory. We did an analysis with an AMD system where we used 8 drives, ran TPCH, and compared it with just having RDIMMs only, and then RDIMMs with CXL, and we saw a 1.96x in terms of overall transaction throughput improvement. Even though the latency was longer on CXL, the total wall clock time was less because it wasn't having to go out back and forth to the disk drive. Going forward, we see CXL 3.0 becoming the mainstay, where now we can build large class memory devices that support load store semantics. So right now you have your local memory that's load store and everything's blocked from that point of view after that. We see CXL allowing us that transition to realize the memory-centric compute model. And then lastly, two architectures that have really grown in the data center, the scale up, which is building up multiple devices that have a large shared memory and they can share each other's memory through a cache coherent fabric. And then scale out, which are the large distributed systems, which tended to leave the shared memory workloads behind. We see the opportunity here to basically merge scale up and scale out, so that as we get to CXL 3.0, 3.1, 3.2 systems, those applications can tend to converge on a standard computing and memory platform.
Thank you, Steve, for that insight. So it sounds like we got the right enablement in terms of the new memory tier that we haven't had before. Support for what we call storage features, persistence, resilience, availability. These are the topics that can keep a storage person up at night to make sure they're there. And of course, scalability, going from terabytes per compute node today to petabytes, so order of magnitude is higher, and hundreds of nodes. And that will allow us to continue to innovate on top of CXL for years to come. But we're still early. The first products are still coming out. The first deployments are starting soon. So a lot of learning to happen. And like I said, NVMe was early 15 years ago. Look how long it's come, and it's still moving forward quite a bit. How can we make sure CXL has a similar experience, right? How do we make sure it launches and it's sustainable and and it continues to innovate on top of it? And we're going to talk about three key components to make that happen. One is the technology ready? Is this the right technology? And second one, are we ready as people? We've been doing quite well for the last couple of decades at least with what we got. How do we shift to this new way of deploying servers and applications? And the third key element is sustainability. We got to build that in. What's the key components? What's the key partnerships? How do you learn and implement key learnings from one product generation to another? Because nothing happens from day one, right? They say it takes 10 years to have an overnight success. So how can we get to that overnight success? First, Steve, I'd like to get your insight into, you mentioned CXL 3.0, 3.1 is where really all the values are going to come in, but we're at CXL 2.0 today. It's going to take time. We feel like some innovation, some key learnings have been implemented. From your view, like the next couple of steps, if you look ahead a couple of years, how do you see that evolving?
Well, first and foremost, in order for a new architecture, the reason x86 was so successful over the years is it ran old software from 10, 20, 30, 40 years ago really well, while it added new capabilities and allowed the software community to kind of catch up with those new capabilities and become more ubiquitous. So CXL 2.0 is really, this is the first time we've had the opportunity to really be part of the virtualized memory system. So by building modules there, putting them in platforms that have CXL, that are CXL capable, we've got a lot of key learnings in terms of what we had to do just from the BIOS point of view and from the driver's point of view and getting the Linux ecosystem and the Windows ecosystems up and running. So this is a matter of just trying to get these things to start working in a normal environment, and then we'll start building innovations on top of that.
Great. The next point we want to talk about is, are we ready as a community? How is the ecosystem evolving? A lot of good things came together last few years to make CXL what it is today. The way we see it, it kind of redrew the sandbox, so to speak. It used to be server is what it is. You get a CPU, yeah, it's faster, new memory, and then the application developers had to deal with what they got, so to speak. And nowadays, like with the CXL built environment, kind of everything got integrated together a little bit earlier. which opens up opportunities for new collaboration models. Feel like we're more coupled together from the component providers all the way to the application developers. Curious to see your point of view, Stephen, like what new collaboration models we could have between the different community members and adopters there that can help us.
Was that a question?
Yeah.
Oh, okay. I grew up in the age where, as one person put it, software was a necessary evil. So we designed this hardware, throw it over the wall, let the poor programmers figure it out, and meanwhile generate the next level of hardware. That was a very, very bad perspective on how things should be. And with the opportunity we have here, we're actually going to start with the applications and the large workloads and tear them apart. And I mentioned generative AI. That's one of the first ones we're looking at in terms of really tear it apart, understand what the needs of the application are, and then build the next generation of CXL memory controllers and modules to be able to assist the software to do a better job and to get results in a more equitable manner.
Great. Thank you. Necessary evils.
Yeah, sorry about that.
The third pillar we talked about or mentioned is sustainability. Any technology that, it's in this phase, we heard about the adoption curve, we got to cross that chasm, is what are the key components, the key elements to make sure that long-term value realization is there? It takes years, like I said, it takes a lot of iteration. So the questions we hear to the community is, when you embark on this journey and look at the long play, the long 10, 15 years from now, where do you want to be at? It's got to examine what key partnerships you can build and establish, such a generation over generation. The key learnings that happen, that Steve talked about, are implemented actually and taken advantage of, such that we continue to innovate and actually do cross the chasm over years. Any insight there you can provide in terms of how Micron is looking at this from a partnership standpoint and sustainable road?
Well, we recognize that there are certain strengths that we have and there are strengths that we don't have. And leveraging not only logic providers and controller providers that in this particular area, but certainly the platform vendors, the processor vendors, anybody that's actually a user, and listening to what they want to do with this technology. When we first started, the big use case for CXL 2.0 was memory pooling. And everybody talked about, we've got this stranded memory that we design our data centers for a worst case condition, and 25% of those resources are used just during the normal time frame. About 7 years ago, we did a TCO, a total cost of ownership analysis of memory pooling. Said, it doesn't really make sense. When they came back and said, we really won't like the memory pooling use case, and chipset vendors were looking at it, and we were struggling to figure out how we would support something like that. The TCO model never changed, and so now memory pooling isn't as interested. So what's happening is this is a new technology, and we're all struggling. How is it going to be used? And so we really do see this first set as a learning case, and it'll help us build relationships. Some will be interested in working together, some will not. And one of the other things we have to be careful of is, from my processor days, any feature we added and there was a piece of code written to it, it became legacy, and you couldn't get rid of it to save your life because there was some application that needed it and it would fail. So we've got to be really careful about what we do here and what we add in, because we're going to live with it for a long time if we do something in a fairly haphazard manner.
Great. Thank you for the insight.
Sure.
So to summarize, some of the key points we made today: look for complete products. Looks like the technology's there, the ability to support interoperability, the reliability features, the latency and performance features to make sure CXL takes off. That is a key component to enabling the application innovation and CXL sustainability over a long period of time. Key partnerships are important. Like Steve mentioned, there's some things some comes in good at, others are not. You got to find the right partners to make sure we're all better together, so to speak. And ultimately, sustainability is a key component here. So how do you enable the right pace of innovation and those roadmaps that take in the key learnings? If you have the right partnerships, the right investments in the right areas, CXL can have a long path to success. Thank you, Steve. Thank you all for your time. Come check us out at booth 419. The CXL module that Mike ran on yesterday is in a demo there, a live demo, soon showing a real-life application with the improvements and expanding memory over CXL. Like I said earlier, a lot of innovation on top of NVMe still going on, so we'll still show you some virtualization demonstration there and performance. And also an interesting demo we have on PCIe fabrics. We embarked on building a fabric out of PCIe, which is not inherent to the spec, but that, as you look forward, is a precursor to CXL fabrics, how it's going to look like. So please visit us at the booth, and thank you all for your time, and it's great to talk to you today. Thank you, Steve.
Thank you.